So in this video we're going to go over a brief introduction to the list interface. So the first thing we need to know is what exactly is an interface? Well, an interface you can view as a contract, which basically says that any sort of class which might be implementing this interface has to implement all of the functionality that the interface states. So it's a binding contract in this case. If we say that we implement an interface, but we don't implement all of its methods, or at least don't have the declaration of each of the methods from the interface, our compiler is going to be very mad and upset about it and give us a little bit of an error. So by default, all of the methods inside of the interface happen to be abstract. So as you can see, we've got this little thought bubble here, which represents a bunch of different methods here. And as you can see, some of these methods look the exact same, but have a little bit of different colors overlapping in them. So it shows that it's trying to show that basically you have a bunch of different methods that are being implemented by different classes, slowly changing what the method actually does, while still promising and guaranteeing that it's going to have its own implementation of what it thinks the function should do. So here we can take a look at an interface hierarchy. So we're dealing with the list. We're dealing with the list interface over here. As you can see, the list interface uses what stems from it is an abstract class here, known as the abstract list. The abstract class implements a couple of the things from the interface itself, but then it also leaves some of the classes to be abstract, or some of its functions to be abstract. And as we can see here, if we take a look at everything below this level here, we can see that a vector, the vector class, implements basically the list interface. The array list also implements, by default, the list interface, and the linked list inherently implements the list interface. So what's the importance of this? Well, remember, the list interface is just a contract which says, hey, I have a whole list of things that I want you to implement. And each one of these classes, which is inheriting the functionality from the list, guarantees that it has all of the methods that the list contract states, and maybe a few methods of its own here. So, okay. So here are some popular methods for lists in the list interface. So add, the add item just appends something to the end of the list, adds something at a certain index, adds the item to the various index in the list, and then kind of shifts everything over. The get index basically checks to see if we have a certain item at a given index in the list and what that item is, if we contain it. Remove item checks to see if we actually have the item in the list. If we do, we actually remove it from the list and then shift things over accordingly to the left. And then size just keeps track of the size of the list. And then an iterator creates an iterator to move through the list. One of the reasons as to why we might use an iterator as opposed to using the indices is because if we use the indices, it would imply that we know something about the data structure that we're using to implement this specific sort of list. Because in some cases, when we're using array indices, or we're using 0, 1 to n minus 1, that might be a little bit different from trying to go through a linked list, because a linked list we have to keep track of, we only keep track of next pointers, and we can't immediately jump from, say, 1 to 6 without having to actually iterate through. So we need an iterator in that case. It's used for, it's just a generic thing that allows us to run through the entirety of the list. Anyways, that's all I've got for now, and I hope you guys found this video helpful.